So another clock came in today. Let's see what this one looks like. A real nice mantel clock. So this one was brought to me by Greg. He brought it up here for a friend. A real nice German mantel clock. Yeah, very nice. And it belongs to an Alex McGregor out of Colfax. Packed it real well. I don't know what's in here. That's the pendulum. I see trademark Junghans, nice German movement. That was a trademark Junghans, came out in about 1890. So I need to get the movement out of here so we can service it, and the first thing we need to do is remove the hands. This hand here is for the chimes. It's to turn the chimes on and off. And that's held in by, the hand is held in by a taper pin. This pin out of here. I always like using these brass screwdrivers on these parts as much as I can because the brass doesn't scratch. And you can see somebody has used some steel screwdrivers on here. There's some scratches on that. And this hand here, the taper pin is missing. It must have fell out sometime in the past. It got a loose washer on. Kind of stuck on there a little bit. There we go. And this hand also has a taper pin in it. I don't see the other end of it here. It's looks like somebody has bent over the end of it. The only way to get that out of there is to straighten out the end of that pin. That first pin I took out was a steel pin, and this one here is a brass pin. Straighten the end out here. Man, that was really bent around there. Okay, that's got it coming out of there now. So to remove the movement, first thing I need to get out of the way would be the chimes. And it looks like this is a 5-hammer movement, and I would assume it's probably a Westminister chime. But the strikes in these German movements, they're very rich and really resonate really highly. But it just resonates for a long time. Real high quality on their chime system. It's mounted in a bronze mount. You get this out of the way so the movement will come out. And here's the chime assembly. And it actually is looks like it was made in America. Bronze mount here was patented November 1st, 1904, and it has a United States patent on it. You can see where they've got a slit in here, this cut in here, to attempt to isolate as much of that bronze material to the mount as possible. And that's why they've always sounded really deep and rich. We'll set this aside. These movements are held in at 4 points. We've got 2 screws on the top. and then there's 2 fasteners on the bottom. I've always enjoyed working on these German movements. They made a good high quality clock movement. Okay, we'll take this out and get it on the bench and take a look at it. So right off, before I even get it on the bench, I can see there's a little bit of a problem. Right here, there's this mainspring gear is missing some teeth. They're broken. 1, 2, 3, 4, 5, 6, 7 or 8 teeth are stripped off of there. So I've got this on the bench, just doing kind of a preliminary inspection, and what I'm finding here is sometime in the past something has happened here on the on one of the mainsprings, on the gearing of it, because it's got some brass teeth that are broken out. Here's one right here. If I can get some watch paper, and there's one of the teeth that still was in there. And also the steel pinion, it's got at least one tooth broken out of it. Here's that tooth. So the movement's going to need a few parts in there. The pinion, it's either going to have a new pinion cut for it, or maybe we can find another movement that has some good parts in it. As far as I can tell, the rest of the movement looks to be in good shape. The oil in all these pivots is either dried up, it's like grease. It's been so long since it's been serviced. Here you can see some oil that somebody in the past has over-oiled it, and the oil ran down the side, but it can't even rub it off. It is like on there like grease. You can see a little bit of the oil residue on that watch paper. And down here at the bottom, you can see where the oil, they put too much oil on it, it all ran down, and it collected on the bottom here, and it's all dried up. But at first sight, the movement doesn't look too bad shape, except for that one tooth on the pinion and the brass teeth on the barrel. Here on the back of the movement you can see the trademark. So the 8-sided star with the J in the middle, and then Junghans, and B10. The B was for the second half of the year as far as production date, and the 10 is 1910, and then down here at the bottom it says Germany. One of the first items I like taking loose on these is the suspension spring. It's because they are so delicate. And this is where the pendulum attaches. This spring in here is very, very thin and very easily damaged. The rod here that allows it to come out, this little area in here. If that wasn't in there, you wouldn't be able to get it out of this piece here. It's in good shape. So in order to get this properly cleaned and get into those damaged parts, I need to disassemble quite a bit of it here. And they're also held together with a lot of pins. These a lot of the shafts are locked in with the gears and pins. And these need to be removed before you can pull the movement apart. Take the pins that came out of each hole and I put them back in so that they can go back into the same spot. These pins have a tendency to be different sizes from each other, and some of the holes are different sizes, and if you just throw them all together you're never going to get the right pins in the right holes again. And this is the governor for the chimes. So I've got everything loosened that would prevent this back plate from coming off, so I can remove the back plate now and get out those damaged parts. This is the pinion that has the broken leaf on it. I've been looking for parts, unable to find this particular part. Here's the barrel with the teeth, has the damaged teeth. You can see how they're broken off there. So here's the piece that has the broken leaf on it. As I turn that around, you can see the steel tooth is broken. So we'll have to make a new one of these. And here's the mainspring barrel. I don't know, 8 or 9 teeth that are stripped off, and there's a couple that are damaged. And then you can see on either side of the stripped off teeth, the first 1 or 2 teeth are bent on there. Not able to locate any parts, so we're going to go ahead and repair these. So in order to get these teeth, to get them repaired, and also to clean the movement, I'm going to need to remove the mainspring from the barrel. I see some previous watchmaker has engraved an R right there, which means the right side of the movement, so they could match it back up. Definitely not the first time that this has been opened up. Pull this cover off of here. Look inside there, see what we can see. It doesn't look like the mainspring is broken. So as I'm pulling these apart, not finding any damage on these wheels. Here's the escape wheel. It's been so long since it's been serviced. Here's the pallet. A lot of grease right here, and that should be light oil. I'm going to get a piece of watch paper just to kind of show here. You can see on the watch paper it was a reddish type of oil that they used, and it's all but turned to grease, even on the pivot ends there. We get these cleaned up and get this grease, this hardened oil out of there. And so now that we got this all cleaned up, we can see the third wheel lantern pinion has some damage. One of the trundles is broken on it. You can see that. That's broken half right there. We'll need to pull that trundle out of there and replace it with a new one. I could make one of those out of some what they call music wire. It's a very hardened wire. But you can see the trundles on these have some end play on them. Some of these lantern pinions were designed so that the trundles would rotate in there like a roller bearing, and as the brass gear runs against them, the concept was that these trundles would rotate and create less friction. And so when I repair this, I will make sure that the new trundle that I put in there rotates. So I've got the trundle removed from the lantern pinion. You can see where it used to go in right here. So here's the broken trunnion, and then here's some stock I have that I'm going to cut a new trunnion from and get it mounted in that lantern pinion. So to replace those trunnions is really important to get the correct diameter, otherwise the gears won't mesh properly. This is the old broken one. I've got this micrometer here which will tell me 0.7 millimeters. So we need to find a piece of high quality steel that's hardened to replace that with. It's got the same diameter. If the diameter is too big, I can go ahead and polish it down, but here's a piece of highly polished hardened steel, and it measures 0.7 millimeters. So I'll be using that piece of steel to replace that trunnion. So I've got the broken trundle out, and the top part of the lantern pinion, the old trundle pressed out, is knurled up here. The hole is just a little bit small where it's knurled for the new trundle to go in. I'm going to take this, just a needle here in a pin vise. I run it down through the hole where the old trundle came out. Very gently take the tapered end of the needle and open up that knurled piece of metal a little bit so that the new trundle can go in. And here's the new trundle, piece of high carbon hardened steel. It's been polished. Slide that in that hole there. So you can see the new trundle fitted in here. I can back it completely out. And to knurl these, I use a pair of knurling pliers. I'll make sure that that trundle is all the way in. And then put these pliers in here, and just to give it a gentle pressure. Doesn't take much. And it'll take the brass on the top and knurl it over so that that trundle won't come out. That should do it. Now that trundle is locked in there like all the others, free to rotate like all the others. We'll go to the next step. So here's the barrel that was missing the teeth in it, and what we did was we just went ahead and made a new barrel top on it and then cut all new teeth in here. So that's going to work real fine. And on this first wheel pinion, this is the one that was missing a leaf on it that was broken. Went ahead and made a new pinion for it and pressed it on there. And the original ratchet wheel had several teeth that were stripped out on it. You can probably see them as I turn it real slowly here. I'll get a little closer maybe. So I've got all the gears installed on the plate. You can see the new barrel end piece that we made here. And I went ahead and left it enclosed. A lot of times they're better that way. It keeps the dust and dirt out of them. Should work just fine. Next step is to go ahead and put this back plate on here and line the gears all up. Get all the pivots in these holes, and we'll get it back together and see how it runs. Just oiling the shaft for the chime mechanism here. We'll put a little oil after it's on. Fits right on like this here. A lot of these shafts are fitted with pins instead of bolts due to the age of the clock. 1909 or 1910, a governor for the chimes. This is part of the mechanism for winding the time. So that's the mechanism that you use the key on to wind the time side of it. This is the wheel for the minute hand. And this is the wheel for the hour hand. So we just need to finish it off with 2 ratchet wheels and we'll be done. There's the new ratchet wheel. Before I put those on, one thing I did notice is this original ratchet wheel is all chewed up here. I'm not sure if this is the reason, but this spring here needs to be either fixed or replaced. Right here where it contacts the click, it's severely worn out there. And it's, I don't know if you can see it, but it's, bring it up closer. There's a hole worn in it right there where the click was touching the spring, and it's almost ready to break through completely. So I'm going to see what I can do about getting another one. If it's too much trouble to get another one, I can either repair this one or make one. It could have caused that ratchet wheel to slip and spin and then break those teeth. We'll fix that. So on this pendulum suspension rod here, got a hole right here. And there's a pin that runs through there. The pin that was originally in there is very short, hard to deal with, and I'm going to go ahead and put a new pin in there. I'll go ahead and, it's a tapered pin, and that's long right there, and I'll cut it right in that area there. And then cut it again right there. And then I'll hand work these down so they're square end on them, and we'll get that pendulum suspension spring in there. Then from there we'll be able to wind it up and see how it runs. We'll get this pendulum suspension spring rod mounted in here. We'll run this in here to make sure that the spring is centered in that hole. And then we'll put this pin in there, fasten it in place. The top of the spring is mounted on this arm that is moved up and down. When it moves up, the clock will gain time, and when it moves down, it will slow the time down. That's how you regulate the mechanism. But I'm going to go ahead and wind it up now, and we'll mount this on a test board. I'll let it run for 24 hours and then time it after that, and should be ready to go back to Alex. So we'll wind this up, get a little power on it. The chimes, and this is the time. And this is the hour striking. Mount it on this test stand. See what happens here. I got a faint little tick there. Adjust the legs on this stand a little bit. And it seems to be running okay. So we've got it mounted up on the test stand. And it seems to be running, probably for the first time in close to 50 years. We'll have to make some adjustments to it. We'll see how this works. I'll activate them here. There's a little lever in the front here. So that part of it's working. Now we need to see if this is going to strike on the hour. This one right here with the chain, that's the one for the hours. And looks like that's working too. I'm going to go ahead and let this run for 24 hours on this test stand and then make some adjustments to it. Put it back in the case and get it back to Alex. So I ended up making a test stand for this clock. A few more adjustments I need to make on it, and I just needed a little better access to it while it's running. The third wheel has been damaged on this movement. If you recall, this is the barrel that had the teeth stripped off of it, and then the first wheel had the leaf broken, and we had to make a new pinion for it. The second wheel had one of the trundles broken in it, and I replaced the trundle. And the third wheel in there, it has just a little bit of a bend on the shaft or either the pivots. I'll get a little closer view with the camera. What was happening was the thing was catching a little bit as it was running. I've isolated it to that third wheel having the shaft or the pivots bent on it. We'll get a little closer view on it. I think you can see it. I'll put it in motion here and you should be able to see that. But you can now see the third wheel. It's got the shaft. It's got either the shaft or the pivots are bent on it. It got damaged when that barrel wheel and the first wheel got stripped, the teeth got stripped out. So I'll go ahead and pull that third wheel out of there and see what I can do about straightening the pivots or the shaft, whichever one is bent. And if we can't get it straightened, I'll have to make a new shaft and mount it in there. So I've got the third wheel here, and I'm going to mount it up in my lathe here to just see if I can determine where that shaft is bent and if the pivots are bent on it. As you can see, let me get a little closer view of it. So I mounted this up so just a little bit of the shaft is in the collet there. And as you can see, this shaft here is nice and straight on here. So that shaft through that area is not bent. But when you come over to this side, that's what you can really see a bend in there. If I push this in so the whole shaft is in there, you see that this collar here is running nice and true, but then the gear over here is wobbling back and forth. So now I'll reverse that. Now that I know that that shaft, this section here is good, we'll put this in here a little ways. And now this gear is running nice and true, and that shaft on this end here where the collet is nice and true, but it's showing it's bent over there. When that mainspring barrel broke, ended up having the teeth broken, all that power went into this, was centered right there where those trunnions are, and it looks like the shaft is bent right there where the trunnions are. So I'm going to do what I can to get that shaft straightened out. If I can't get it to straighten out where it needs to be, I'll have to make a new shaft and mount it in there. So with it mounted in the lathe, I can take my tailstock off here. I've got another collet that fits that shaft on here, and we'll mount it into this piece here. Now that shaft is nice and true in this piece, and the shaft is also nice and true in this end here, and that just leaves the center portion there that is bent. And so what I can do is this out here that's bent, I will move it up or down wherever it needs to be. It doesn't take much. This here just as an indicator. Now that I've got it that close, I'm going to use a felt pin here to mark just exactly the high spot where it's bent here. Then wherever it touches here, I'll push it in the opposite direction, just ever so slightly. And that's looking pretty good. I'm going to go ahead and work on it a little bit more and then put it back in the movement. It's been running for 4 days now. Still needs a little bit of timing. It's just a little bit slow. To time these, there's 2 different locations. You've got this little lever that goes up here, and you can turn this right or left, and what that does is it works a cam in the back here. If I can get the camera up there. And this is a pretty good shot of that cam. This little hand goes on the front here, and the dial is on the front. As you rotate this to the right and left, you'll see the shaft that goes through here, and it's working a cam right here. And it rides against this rod. Let's swing it around to the back and see what that's doing. As I rotate that hand, you'll see that this suspension spring is being pulled up and down, and as that pulls that suspension spring up, it makes the clock run faster, and as that suspension spring goes down, it makes the clock run slower. So that is one point where these Junghans can be adjusted from the face. And then for a finer tuning adjustment, we'll follow this suspension spring down to the suspension rod. Because here's your suspension spring. You can see it's a small spring, and then it's connected to the suspension spring rod, and as that rod goes down, you've got the pendulum. And the pendulum has an adjustment on the bottom here. If you screw this down, the pendulum comes down and it'll run slower. And then as you screw that to make it go up, the pendulum goes up, and that'll make the clock run faster. So I'm going to time this first using this cam mechanism up here, and once I get it pretty close with that, then I will in turn go down and do the fine tuning with the pendulum. So a few things that I had to do to get this running was the ratchet wheel, the old one. Some of the teeth had been damaged and stripped on it, so we had to make a new ratchet wheel. I tried to locate one from the parts house, but they just did not have an exact fit. We had to make a new ratchet wheel. That's the new wheel there. And then the click spring was damaged. It had a crack in it. Didn't want to put it back in there because that crack would have eventually broke. So I made a new click spring here and put that in there. Around the side, this barrel gear, it had 8 or 9 teeth stripped out of it. We made a new barrel gear top. The pinion, this first wheel pinion was damaged. It had one leaf that was broken on it, so we made a new pinion. The second wheel had a broken trunnion in it, and I replaced one of those trunnions. And then the third wheel, if you remember, had the bent shaft on it. We went ahead and straightened the shaft. This mechanism in here is running nice and smooth now. So I'll take a few more days, get this timed. So it's time to get this off the test stand and put it in the case. So we've got the movement mounted. I'll put the pendulum in.